So lesson 6.8, we're going to be looking at the standard equation of a line. So we've been looking at a whole bunch of different forms of the equation of a line. We looked at the slope-intercept form, y equals mx plus b. And we looked at the point-slope form, y minus y1 equals m times x minus x1. Both were useful in different circumstances when we needed them. And today we're going to look at a third one called standard form of the equation of a line. It's important to remember that all of these are equivalent. Every line has an equation that can be rearranged into one of these forms, and they each have a purpose and a reason that we use them. So standard form looks like this. Every line has an equation of the form ax plus by equals c. So we know how to arrange that into y equals form. We know how do we set up an equation where we can plug in a point and a slope, and now this is standard form. So a, b, and c are going to be numbers, and you're going to have the x and the y. And we know how to get that into y equals form. We've looked at equations in this form. If you take a look at these, we've seen stuff like this and rearranged it into y equals mx plus b, solve for y. And there was a reason for that. But we're going to look specifically now at equations in this form. How are they useful? What can we do with them? And why do we need to study it? Certain word problems or certain situations, real life situations, are going to fit perfectly into this kind of form. So we want to make sure we understand how we can use it. And then, of course, how can we get into the other forms as well from here, which we already kind of studied. All right, so that's your standard form. We are going to run into this word oblique, and so we want to make sure we know what that means. So it's a line that's not vertical or horizontal. We know our horizontal lines have equations that just say y equals a number. So a horizontal line says something like that, and a vertical line that goes straight up and down and hits the x-axis, okay, is going to have an equation of just x equals 2. And so how that's going to come in this section is these equations aren't going to be able to look like this. Now, they technically can be in standard form, but the y here would have a coefficient of 0, so it's gone, and the x here would have a coefficient of 0, and so it's gone. And so all you see is the x and the y, so it's not going to look like standard form. But that's where that word is going to come in, is we want to really study oblique lines, and those are just diagonal lines, basically. So we're really going to be focused on diagonal lines, not as much our straight up and down vertical lines or our straight side to side horizontal lines. All right, so let's slide down to example number 1. The following equations are written in standard form. We're going to identify the a, the b, and the c. We're going to find the x and y intercepts, and then we're going to put it on the graph using those intercepts. So instead of putting this into y equals mx plus b form, which we could, and using that to graph, we're going to use our x and y intercepts to do so. Now here's one reason why maybe you would want to do that. Sometimes, and not necessarily for these specific ones that you see here, but sometimes if you try and arrange something into y equals form, you can get a pretty nasty decimal or fraction for the y-intercept. And so if you're trying to put your y-intercept on your graph and it's 3.278, well, where is that on my graph? It's kind of hard to find. Okay, so standard form can help us find our intercepts, which a lot of times will be more useful when trying to put it on the graph in a situation like I just discussed. Okay, so there's a reason for this. All right, so we're going to identify our a, our b, and our c. A is 3. Notice standard form is supposed to be a plus. So when I see a minus, that actually represents a negative number. So our b is -4. So we're going to have the x and the y on the same side of the equal sign if we're in standard form. And then if there's an extra number, which we've usually kind of turned into, or it's been part of our y-intercept when we rearrange this, that number is going to be by itself. So c equals 12. If we slide over to this one, while we're identifying, let's look at this one. The a is 5. Again, we have a minus here. So the b is a -2, and my c is -10. All right, next we're going to find the x and the y-intercepts, and I want you to think about how we can do that. So if we wanted to find an x-intercept, that's what we're going to start with here. Right under this, we're going to find the x-intercept, and right under this, we'll find the y. Anytime we hit the x-axis, say right here, the x has a value of 5 and the y is 0 because it's not up or down. And when we hit a y-intercept, there's a y value, but the x value is 0. So anytime you want to find the x-intercept, all you have to do is plug in 0 for y, not for x, for y, and that'll tell you where it's going to cross the x-axis. That's the point on the graph that the x has a value, but the y is 0. And the opposite's true for the y-intercept. If we want to know what the y-intercept is, we're going to come over to the x and plug in 0, because on this graph, when it hits the y-axis, it's going to have a value for y, but the x is going to be 0. Wherever that line is, the one point that it hits that axis when the x is 0, that's going to be your y-intercept. So here's the basics. If you want to find your x-intercept, we need to know when does y equal 0. What's the ordered pair that makes this equation true when y is 0? So you're literally going to take the equation and you're going to plug 0 in for y. And it's really easy math because 0 pretty much just clears things out. So 4 times 0 is just going to be 0. You don't have to write minus 0. All that's left is 3x equals 12. And we know we're going to divide there and find out that x equals 4. So the x-intercept is 4. 1, 2, 3, 4. So we already know this line is going to hit right there. Now remember what that point is there. X is 4, y is 0. That's the x-intercept. So to find the y-intercept, it's kind of like the opposite. Wherever it hits on this line, the y is going to have a value, the x is going to be 0. So to find your y-intercept again, you're going to have to find out where is x 0, because wherever this hits the y-axis, there's going to be a y value, but the x is 0 because we're not to the left, we're not to the right, we're on the axis, which is x equals 0. So we're going to plug in 0 for x. So we're going to rewrite the equation starting over. 0 goes in for x. Basically clears that out. So you have negative 4y equals 12. You're going to divide by negative 4. And so y equals negative 3. So my y-intercept, where it hits the y-axis, is at negative 3. So by plugging numbers in, now we chose specific numbers of 0, but technically you can plug any number you want in and solve for the other value, and it's going to give you a point on that line. So this value right here is the point 0 for x, negative 3. So we plugged in 0 for x and for y and found out x was 4. We plugged in 0 for x. I said that backwards. We plugged in 0 for y and we found out x was 4. And then we plugged in 0 for x and found out y was negative 3. You can go in there and plug 1 in for one of these, like we've done in the past, or 2, or 10, or 100, and find the other one, and it's going to be a point on the line. But these are specific points that really help us, give us those intercepts, and we're going to look later at how they're going to help us even more. So I can draw my line, and I'm all set. So finding your intercepts makes it very easy to graph. Okay, so let's take a look at the second one. We're going to start by finding our x-intercept. So to do that, you got to find out what is x equal when y is 0. So I'm going to plug in 0 for y. Clears it out. So I have 5x equals negative 10 divided by 5. X equals negative 2. So I know this is going to hit the x-axis at negative 2. There's going to be a point right there. And my y-intercept, where this is going to hit the y-axis, all I got to do is find out when x equals 0. So plugging that in, 5 times 0 for x minus 2y. So that clears out. You have negative 2y. You're going to divide by negative 2. And a negative divided by a negative gives you a positive. So y equals 5.